I'm Anil Kumar, and here is solution of question number 7, page 146 for my student Ryan. Now the question here is, a rancher has 1000 meter of fencing to enclose two rectangular corrals. The corrals have the same dimensions and one side is common. What dimensions will maximize the enclosed area? The figure given to you is kind of like this, right? So that is the enclosure, and right in the center we have partition. Imagine this is right at the center, right? Now let us say that the dimensions are, we have these sides as, let me write these sides as, in this particular case I'm taking this as x for the time being, right? So let's say this width is x and this is y for me, right? So let us say these are the dimensions for my fencing, right? So it says that rancher has 1000 meter of fencing. That basically means that sum of all these sides, that means there is 2y, 3x, right? So we have perimeter, which is equals to 1000 meters, should be equals to 3x plus 4y. Do you see that? 4y. So that is how we can relate both the things, right? So 3x plus 4y is how we can relate all these sides, correct? Now in this particular case you could write one variable in terms of the other. For example, you could say that x is equals to 1000 minus 4y divided by 3. So that is the value of x. Now you need to maximize the enclosed area. So we say area will be length into width. Now length for us is 2y, right? So length for us is 2y and width is x for us, 2y times x. So what we'll do is, instead of x, we'll write this expression which we got in y. So we can now write this as 2y times 1000 minus 4y over 3, right? So we got one expression in y. So we can say area in terms of y, one particular dimension, is all this. So let's open the brackets. It's kind of simple, right? So we get 2000 y over 3 as the first term, and then the second term will be 8y square over 3, right? It's not a bad idea to actually expand this and then find the derivative. Since we need to find the critical number, derivative for this is 2000 divided by 3, and derivative of this term will be 2 times 8, which is 16 divided by 3 y, and for a critical number that has to be 0, right? So this is for finding the critical number. So we need to find critical number. So that means the derivative should be equal to 0, right? So that helps to find the critical number for us, right? Now in this particular case, if you solve, so we can solve it on the right side also, or you can say 16 over 3y should be equals to 2000 over 3, right? So now we'll solve this on the right side of the page. So what we have here is that the y value should be equals to 2000 divided by 16, right? You can use the calculator to find the answer. So it is 2000 divided by 16 equals to 125. Now that is this y. That means 125 here and 125 here. So 125 gives us 250 along the length, correct? So that is the y value. As far as the x value is concerned, we can find x from the expression here, which is 1000 minus 4 times 125 divided by 3, right? So that is equals to, let's calculate this also. It is 1000 minus 4 times 125, and then you divide this by 3 to get the answer. In decimals, it is, you can write this as 166.7, correct? So that becomes the x value, right? So it says what dimensions will maximize the enclosed area. So in the given diagram, y is 125 and x is 166.7. right? So that is how you can find. If you need to find maximum area, let us say, if you need to find, if suppose in your test the question is to find maximum area, then your maximum area will be 2 times y, 2 times 125 times the width, which is 166.7, right? So that will be, let's multiply 2 times 125 times 166.7. So approximately that is going to be equal to 416.75. The units are meter square, right? So that is approximate value for the area, maximum area, right? But the question is, what dimensions will maximize the enclosed area? So you can say that the length is 150. So you can say each corals will be 125 by, so you can write answer as 125 by x is 166.7 each, you understand? So both are the same area, right? So 125 by this, and the units are in meters. You get the idea, right? So it is each. So that might be creating a confusion for you. So that is how you should be solving this particular question, right? As far as the boundary conditions are concerned, you can actually use this relation to find the boundary conditions, correct? So y value could be 0. So the boundary conditions also you can test. So y for you is greater than or equal to 0, and this cannot be negative, right? So 1000 divided by 4. So 1000, you know half is 500, 250 is your answer. Anyway, let's divide 250, right? So y value is between 0 and 250, but any value you put, so a of 0 will be 0 and a of 250 will also be 0. So these boundary conditions will always give you that result. Therefore, the answer gives you maximum area. So it's also important to mention this in your solution. So when you provide the solution, sketch the diagram, be clear, define your variables, relate them, find relation between area and the variable, single variable, find the derivative, find boundary conditions so that you can figure out whether you have absolute maximum or not. Check the values on the boundary conditions and at critical number, right? For us, the critical number was 125, right? So that was the critical number, right? So the area was calculated for 125, and that is how it should be done. I hope it helps. Thank you and all the best.